Okay, 4.1.1. This is a review of 4.1.1. Mainly you had to learn how to say, if I have 30 degrees, what is that in radians? And you're going to be able to say, oh wait, that's percent, sorry. Units are important. And you'd multiply that by pi over 180. So to get degrees to change, you want the degrees on the bottom. Okay, pi over 180. If you had radians, if you had like 2 pi radians, you'd multiply by the other way around, 180 over pi. Okay, and then the third thing I asked you to think about was, what's that formula that gives you arc length? S equals theta r, and you should have said in radians. You can't do this formula in degrees. So you got to get really good at radians. So what's the new stuff? The new stuff is about radians. A lot of it's about radians. So let's talk about, first of all, degrees. What would 30 degrees be on this? Well, there's two kinds of, or two parts to the angle. There's the part you start with and the part you end with. And if I make my angle end right about there, do you agree that'd be like a 30-degree angle or so? Okay, and this would be like a 60-degree angle or so? All right. So that's called the terminal side. The one I'm moving here, that's called the terminal side. Do you remember what the other one was called? Start with an I. Initial side. Okay, so the initial side stays put. It stays right there. This side moves, and you get your terminal side of the angle. So when they ask you for that on the worksheet today, they're going to say, where is the terminal side of the angle stopping? All right, well, here's 30 degrees, here's 60. 90 goes straight up and down. I didn't have a very straight circle there drawn there with the axes, but this would be 180. And of course, all the way wrapping around like this would be a 360-degree angle if it goes all the way back to normal. Okay, so again, back to a 30-degree angle. You're going to have to start memorizing spots where the radians are. If that's about 30, it's also known as pi over 6. I'm going to give you a list of ones that I would memorize if I were you, because they're going to come up so much. Like this next 2 months, you're going to have to know these. So if you fight memorizing them, you're just wasting precious time. Might as well memorize them now. Okay, so 30 goes with pi over 6. Okay. Could you do a conversion and put the mole factor and multiply by, pi over 180 or 180 over pi? Sure, but it'll take forever. So we need to memorize a few. What do you think is the next logical one after 30 degrees that you're going to use a lot in trig?
45 or 60.
Yes, 45 and 60 are both good answers, so we'll go to 45 next. Okay, so this guy goes up to about a 45-degree angle. And at 45-degree angle, of course, I'm going to have it 45 degrees. But can anybody do that conversion quick in their head? Pi over 4. All right. Now, if you're going to try to have a way of thinking this through for what are the pi things without the conversions, then here's what I want you to think of. This all the way around here, all the way around, 180 is a really important one. At 180 degrees, do you remember multiplying by that factor over and over and over again? What is 180 degrees? It's pi. If 180 is pi radians, that means 3.14 radians, then if the whole way is 1 pi, do you get that halfway would be half of a pi? Pi over 2. Does that make sense? If all the way is 1 pi, then halfway is half of a pi. And this is 1/4 of the way, so it's 1/4 of a pi. All right, let's keep going with that theme of the even ones like that. So if this is 1/6 of a pi, if the whole pi is all the way, right? That's 1/6 of a pi. This is 1/4 of a pi. And now let's just see what the other ones are that are kind of like that. If that's 1/4 of a pi is right here, then if I double that and I go to 2/4 of a pi, it's supposed to go up to 90. This is supposed to be a 45-degree angle right here. Okay, so this is supposed to be double that. So this is pi over 2. Half of a pi. If that's 1/4 of a pi, 1/4 of a pi, and this is 1/2 of a pi, then do you get that this spot right here would be 3/4 of a pi? And then this spot right here is 4/4 of a pi. It's a whole pi, see? So I'm going to start my circle over again just to let you think about it that way. If I'm saying all the way is 1 pi, if that's a pi, what's that spot right there then? Half of a pi, pi over 2. That's half of a pi. If that's half of a pi, what's that spot right there? 1/4 of a pi. What's this spot right here? 3/4 of a pi. All right, now, this next spot really messes with people's heads. So I think if you count it this way, it won't be that bad. If this is 1/4 of a pi, this is 2/4, 3/4, 4/4 of a pi. What's that spot? 5/4 of a pi. Is that also a number of degrees? Yeah, it is. It's 180 plus another 45. So it's like 225. Do I actually expect you to memorize that 225 is 5/4 of a pi? No. But if they show you an angle in this position, and they just have, all they have is this right here, you're expected to know what that spot is. I'd do it by counting up and go 1/4, 2/4, 3/4, 4/4 of a pi, 5/4 of a pi. I could put the pi on top if I wanted to say 5 pi over 4. Be the same thing. Okay, 5/4 of a pi, I hope you know what's coming. 6/4 of a pi. And 6/4 does reduce. 3 pi over 2, also known as 6 pi over 4. And then, of course, if I just stick with that same system, 7 pi over 4 is not far behind. Eight pi over 4, divide that out, what do you get? 2 pi. Does it make sense that it's 2 pi? If 180 was 1 pi, then it makes sense we'd be back to 2 pi there? All right. Can you keep going? Yeah. In trig, you don't just stop at the end of the circle. If you want to, you can keep going. Let me show it to you. If you had a normal circle and you were thinking 360 degrees, would you get that if I opened up my angle all the way around here at 360, but if I go further and I go like this, starts here and it goes all the way around and then past it, so that'd be 360 plus another 90. It's the idea of like a snowboarder going off of a half pipe or whatever and doing a 360. They're going around once, right? You heard of a 720? That's them going around twice. Same idea. You can go around here past 360 and keep going. So our angles can get bigger than 360. All right, these are the ones that are the even ones. Or sorry, the ones, yeah, well, they're even denominators. Now let's do a circle like this that's based on the ones that are like 30 degrees or pi over 6, smaller chunks. Okay, so if that's like a 30-degree angle, which is like pi over 6, or 1/6 of a pi. Sometimes easier to think about it that way. 1/6 of a pi. Then this would have to be twice that, right? Which would be what? Come on. 2/6 of a pi. Which also reduces to what? Pi over 3. I didn't really draw that in the best spot. I'm going to make it a little bit bigger. This should have been a little bit bigger to be 30 degrees. And then this should be 60 degrees is more like here. In fact, I'm going to get a nice clean circle just a second. Do you guys have a Notability? Do you have a circle drawing tool? Okay. Now I'm going to start in about what I think is the center. That's the initial side. That's the terminal side. And I can make it stop wherever I want to. 30, 60, 90. So now I'm doing like the 30s here. Okay? So if I say that's about 30, it's like 1/6 of a pi. This is like 6. This is like 60. That's like 2/6 of a pi. And you can reduce it later to what? 1/3 of a pi. This would be like 3/6 of a pi, or also known as a half a pi. We already had that one. Okay, we just hit it again. Now, this will be like 4/6 of a pi. Also reduces to 2/3 of a pi. 5/6 of a pi. And of course, 6/6 of a pi. And 6 pi over 6 just cancels to just pi again, doesn't it? All right. So, do you get how it could be complicated or make your life complicated if you didn't know how to do this? If they said, okay, what angle is that in radians? We'd have to go, okay, well, how big is this wedge right here? That wedge, whoa, sorry. That wedge is like a 30-degree wedge. So then really I got to count by 30s or pi over 6s. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, makes sense. Matches up with that. 7 pi over 6. Okay. So you're learning about where these things are. So a typical homework question will say, here is a axis, an XY axis. Show where 5 pi over 6 is. Well, I'd say to myself, well, okay, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Right there. 5 pi over 6. Does it have to be more accurate than that? Nope. Now, would you have to be able to tell me how many degrees is left, like from here to here? Yeah. How many degrees is that little wedge then? 30. If I had to do that in radians, 30 is also known as pi over 6. Good. Okay, now I'm going to give you a memorized list. If you had these memorized, it would make your life a lot better. Just 2 seconds ago, I asked you, what's 30 degrees? Pi over 6. You have to memorize that. You just have to know 30 is pi over 6. Now, some of these are going to naturally follow. Like 60 is twice that big, right? So 60, and by the way, I would seriously, right now, make a notability doc just for what you should memorize for this class. Now, granted, I'd love it if you could just reason it all out every time, but it'll take way longer than if you just simply memorize them. So make yourself a nice list that you're memorizing. I'm not going to give it to you. I'm not going to print it all out for you. You're going to have to make a list. I'll tell you what to memorize, but you make your own list. If 60 is double that, then it's got to be double the pi over 6, which would be 2 pi's over 6, right? And you could reduce that to, if you wanted to say 2 pi over 6, that's not a bad start, but then you should reduce it to what? Pi over 3. Okay? $30, 60, well, the next logical one is 90, right? 90 degrees is 3 pi over 6, which is what? Pi over 2. All right, one I missed in there that's kind of important. We use it a fair amount. There's a 30, 60, 90 triangle. What other kind of triangle is there? The 45. So we got to squeeze the 45 in there somewhere. 45 would be what? Pi over 4. Here's one dumb way to remember it. Do you notice? We're going to have pi over 1, which is just pi, is 180. Pi over 2, we have that. We have a pi over 3. We have a pi over 4. And we have a pi over 6. What's the one thing we'll never use? We've done every number up to 6 except what? So pi over 5 is the only number now you're going to use. See what I'm saying? Pi over 1 is something. It's just pi, which is 180. Pi over 2 is 90. Pi over 3 is 60. It just goes backwards, unfortunately. Pi over 4 is 45. Pi over 6 is 30. The only one we skipped was pi over 5. Now, is it something? Yeah, pi over 5 is something. It's just not a nice number of degrees. Not a kind we use a lot. We use these because they come up in those 30, 60, 90 triangles. Boom, boom, boom. This is the 45, 45, 90 triangle. And you're going to start using things beyond triangles. That's why we have to have things that are bigger than 180, or bigger than 90, sorry. So like 180, etc. All right. If you had these memorized, you could just fire them off. It would make your life a lot better. Those are the ones we use a ton. And it's really easy if you, of course we could add more to this, but if you wanted to add just one more, it would probably be 2 pi, and that's super easy. You just double it, right? So what is it? 2 pi is 360. Remember what we've got here. We've got radians on the one side and degrees on the other side. But I never label them as radians because radians don't have a label. Okay. So again, typical question, they might say, where is 3 pi over 2 on this picture? And you'd have to say to yourself, okay, well, where's, what I'd say to myself, where's 1 pi over 2? Or just pi over 2? I got that memorized. Do you? 90. So 1 pi over 2 would be right there. So then where's 2 pi over 2? Right there. So where's 3 pi over 2? Right there. 3 pi over 2. That's where 3 pi over 2 is. That's the answer. All you have to do is draw a line right there and label it with 3 pi over 2. Okay? And technically, the angle is going like that. Starts there and opens up all the way around to there. These other 2 lines I drew were just kind of helper lines for me. So let's do one. Draw me an axis and show me where 2 pi over 3 would be. First figure out where 1 pi over 3 would be. Then figure out where 2 pi over 3 would be. Again, if I'm ever figuring out 2 pi over 3, first I'm going to figure out 1 pi over 3, and then I'm going to double it. Another way to think of it is, this is a whole pi right to here. That would be a whole pi. Isn't this less than a whole pi? How much is it of a whole pi? It's 2/3 of a whole pi, isn't it? So then it's 2/3 of the way there. So hopefully you went about 2/3 of the way there and you drew your line like this. I'm off a little bit though. That's like 3/4 of the way there. So 2/3 up there. There is where 2 pi over 3 is. Another way to think of it, 1 pi over 3 was 60. And if you have that memorized, you'd be like, boom, 1 pi over 3, or pi over 3 is 60. So I know that 60 is like right there. So then I just have to say this and then double it. Okay? It starts, I was off a little bit. Again, I don't expect you to be perfect. I'm not going to be perfect. That's about 1 pi over 3, and that's about 2 pi over 3. Okay, how about another way to do it? What if I say, here's something that's really close to there, but not there. I'm going to give you a clue. This is 45-degree angle left. Then how much was that? Something pi over something. Try it. Turn it my way and tell me what you think it is. You think it's 2 pi over 3? You're wrong. Something like that, though. You're correct, sir. Yes. Actually, if you guys could just leave them turned my way, that would be awesome, because then I know I've already checked you two. Yep. Zoom in more. Can't read it. Yep. That's in degrees. I want it in radians. That's that pi over 4 kind of deal. Yes. It's not 1 pi over 4, though. I'll give you that hint. Keep it turned my way, though. Just tilt it, set it on its little tilt-tealy bob, so it can just stay sitting there looking at me. I'm sorry, I know it takes away your iPad for a second, but you're really not supposed to do anything with it anyway. So, yes. Yes. I'm now not knowing who I checked. So then, if I haven't checked you, just put a little hand up or something, and I will gladly tell you. Yes. Thank you. Yes, you got the top part right, but it's not actually 3 pi's. It's got to be over something. Yep, that's it. Can you make your brightness brighter? Can't read it. Good. And yes, yours was right. Okay, good. Thank you. So, as you guys get used to that, it'll go faster. 3 pi over 4 was right, because this would be 1 pi over 4. This would be 2 pi over 4. No, I'm wrong. Yes, sorry. Yes, this would be 1 pi over 4, 2 pi over 4. That's just not very straight. And this is 3 pi over 4. All right, so that's 3 pi over 4. All right, how about another one? What would be down here? If, assuming this is a 45-degree angle again. I'm not going to mess with your head and say it's pi over whatever. All right, this time check with diagonal person. The person I set you up with, or sorry, across from the row person. See if you got the same thing as them. If you didn't, maybe you guys can like argue it out and see if. Once you had the idea that this was pi over 4, and this is 2 pi over 4, 3 pi over 4, you just keep going. 4 pi over 4, 5 pi over 4. Awesome, I saw a lot of that answer on a lot of papers. Okay, so where would 13 pi over 4 be? Do you get, you just keep going? I'm at 5 pi over 4, 6, keep going. Figure out where 13 pi over 4 is. Where would 13 pi over 4 be? Just keep counting it out. 1 pi over 4, 2 pi over 4, 3 pi over 4. Just keep counting it out. How many of you get that this is kind of a trick question? Because it's in the same exact spot, isn't it? Here, 5 pi over 4, here's was 3, 4, 5 pi over 4, 6 pi over 4, that's 7 pi over 4, 8 pi over 4, 9, 10, 11, 12, 13 pi over 4, I'm back in the same spot. Now, that is called something. If you're back in the same spot as you were before, it's called coterminal. It's got the same answer. It stopped in the same spot. You know what I mean? This is where that ray was opening up and it stopped here. Well, it stopped in the same spot as something else. So this is called coterminal with 13 pi over 4. They're the same thing. They come out to the same place. It's sort of like saying, if I'm going to start here and I do a 360, you get I'm going to end up in the same spot, it's looking the same way. And if I do a 720, it's going to be still looking the same way. You know what I mean? It's called coterminal. It terminates, stops in the same spot. Okay. Next. What if I say 2 pi over 6s? Except I write it separately and say 2 times pi over 6. Do you get this exact same thing as 2 pi over 6? Which is the exact same thing as what? Reduce it. What is it? Pi over 3. So that's really pi over 3. And if you had memorized it, you'd have it right now. What is it? 60. Good. That's a 60-degree angle. All right. You need to memorize these puppies. But if they have a little multiply problem, just actually multiply it out. It turns into just a multiply and reduce fractions problem, and it's super easy. Okay. Next topic. What if I go negative? Like negative pi over 4. What does that mean? Well, it's the same idea, just opposite what? Opposite way. So if this is 1 pi over 4 is going up like this, 1/4 of a pi, wait a minute, that's more like there. That's pi over 4, or 1/4 of a pi. The negative 1/4 of a pi just goes down the same distance. Same, not the same direction, same distance. Same degrees. So that's positive pi over 4, that's negative pi over 4. It's just going the other way. So you knew there was 30 degrees. Did you know there's a negative 30 degrees? Yeah, it's just going down instead of up. Show me where negative 3 pi over 4 is. Negative 3 pi over 4. Maybe you should figure out where just 1 pi over 4 is. And again, if you have those memorized, it's so much easier. pi over 4 is like a fourth of pi, 1/4 of the way here now, because we're going negative direction. So 3/4 of the way there, because that's where pi would be. So 3/4 of the way is like that. And that's where your negative 3 pi over 4 is. Raise your hand if you had it right. Okay, good. We're almost done. What if I change this into degrees now? I think you're probably still better at degrees than you are at radians. So if I say, where is negative 270? Could you find that? I'd say it's 3 sets of 90, because it makes 270, right? Negative 270. Figure it out. Figure out where you think it is. Show person next to you and see if you agree. Their arrow goes in the same spot as yours. Okay, so that one should have been like this. Negative 270. Negative, that's really like negative 90 times 3. Here's negative 90. Here's another negative 90. Here's another negative 90. There's negative 270. Did you agree? All right, good. That's coterminal with positive what? Positive 90. Or yes, if you go with radians, you're already thinking in radians. That's awesome sign, because if you start thinking in radians, this is so much easier. It's sort of like if you get really good at German, you can actually start thinking in German. If you get really good at radians, you start thinking, instead of saying 90, you start saying pi over 2. That's awesome, because pi over 2 is 90. But if I want the answer in degrees, it would be 90 degrees. But pi over 2 is also a right answer. It's coterminal. It's just in radians. Shares the same terminal side. All right, I think you got it. So the worksheet is 4.1.2, and I'll put one up on the screen here. Hopefully you can find it on your iPad. 4.1, number 2. For each angle, draw the terminal side in the correct quadrant, draw the reference triangle, and label the reference angle. That's the only part I haven't told you yet, and I'm going to show you that right now. The reference angle stuff. All right, so where is 2 pi over 3? Well, I'd first ask myself, where's 1 pi over 3? Pi over 3 is like 60, right? So 2 pi over 3 is like 120. It's like 2/3 of the way there. So here's where about 2/3 of the way there is. Okay? Now, did you get I can't draw a triangle that has a right triangle using this right here? That cannot be a right triangle, can it? So you have to draw a different triangle. Your side is going up here, and so where you make the reference triangle is the only right triangle you could make, which is going straight down like that. There is your reference triangle. It's the same line we had, 2 pi over 3. It's just you drop straight down from that to the x-axis. And that made a triangle. This right here is called the reference angle. The reference angle is how much is left in there before we get to 180, which is 1 pi over 3. That's this little angle right here. Right there. All right, let's do another one. 3 pi over 4. Well, that's 3/4 of the way. There's 3/4 of the way. So that's 3 pi over 4. Where's the triangle? Just drop straight down. Boom. Where's the reference angle? That guy. And it's how much is left. How much is left? Pi over 4. Get it? 1 pi over 6. It's like 30 degrees. Drop down. Triangle. Reference angle. Right there. 30 or pi over 6. Okay. That's all I have for you for today.